Hello all, today in this video lecture I am going to discuss about the impulse invariance technique problem. This is the second type of problem which you may encounter in the examinations. Now generally in the impulse invariance technique problems they used to give the h of s. So then we will convert the h of s into h of z by using the impulse invariant technique. So for converting that, you have to substitute you have to split the h of s into sum of individual poles. So this thing can be achieved with the partial fractions. So this topic I have discussed in the previous video lecture of the impulse invariance method. Now see the tricking part of this question is here in the question they didn't give you any h of s, right? They didn't give you any h of s. So but they have given the hint as third order Butterworth digital filter. You have to take the third order Butterworth digital filter, right? So it means that you have to know the Butterworth polynomial of the order 3. Generally if the specifications were given, then we are going to calculate the order, and from that order we will calculate the h of s in case of Butterworth filter. But here they didn't give any specifications, but the clue they have given is third order, means n is equal to 3. For n is equal to 3, what is the Butterworth polynomial? S plus 1 into s square plus s plus 1. So this is the Butterworth polynomial of the denominator, right? So the total h of s will be coming into 1 by s plus 1 into s square plus s plus 1. Okay, now h of s we have obtained. Now the target is we have to find out the we have to convert this h of s into h of z. To convert that h of s into h of z, we have to split the entire h of s into sum of individual poles, right? So and to do that I have to apply the partial fractions, right? So I want to apply the first order partial fractions. For that I have to split this s square plus s plus 1 as like this. Okay, for that I'm finding the roots of s square plus s plus 1. So this is the formula for calculating the s square plus s plus 1 roots. So the formula is minus b plus or minus b square minus 4ac by 2a. Now here in the place of b you have the coefficient 1, in place of a you have coefficient 1, in place of c you have coefficient 1. So after substituting these formulas you got the roots as minus 1 by 2 plus or minus j into root 3 by 2. Okay, so minus 1 by 2 is minus 0.5. Plus or minus j into root 3 by 2 is equal to 0.866. So these are the roots. Now these roots have been substituted in the poles s minus r1, right? So s minus r1 means this is the root 1, this is r1, this is r2, or this is r1. If you implement minus here, this will be the r2 also. S minus r1 means s minus already 0.5, minus into minus will turning into plus 5. S plus 0.5 minus 0.866. So these are the roots. This is the way how we have written the roots. Now my total h of s will be turning into like this. Now I will apply the partial fractions. Okay, now I will apply the partial fractions. I will split the equation into a by s plus 1, b by s into s plus 0.5 into j of 0.86 plus c by s plus 0.5 into j into 0.866. So first order partial fractions I am applying. So for doing that, now the h of s is equal to, I am taking the LCM of these two, this one and this one in the denominator. Next if you take this as denominator, this is the simple mathematical calculation. So you will have s plus 1 into s plus 0.5 into plus j 0.866 of s plus 0.5 minus j 0.866. So now here you will get a of these two terms, plus b of, so b is having this denominator, right? Apart from this denominator, so you will get s plus 1 and this denominator. So b of s plus 1 into 0.5 minus j into 0.866 plus c is having this denominator, right? So apart from this denominator, these two will come into multiplication of s. So s into s plus 1 into s plus 0.5 plus j 0.866. Now the next target is to find out the a and b and values. So now h of s, this denominator and this denominator, h of s is equal to this, right? This will be same. So you are going to cut it off. So this will be equal to 1. Now you have to substitute the a, b, you have to find out the a, b, c values. To find out the a, b, c values, so if you want to have a value, you have to make b value and b value, c value is equal to 0. So you have to take this such a value of s so that b and c should be 0, right? So here b is multiplied with the s plus 1 and b is also here also c is also multiplied with the s plus 1. If I am taking s value is equal to minus 1, so minus 1 plus 1 will turning into 0, and here also minus 1 plus 1 turning into 0. 0 into something, this total term will be 0, and 0 into something, this total term will be 0. So b and c will be cancelled each other, so you will get only a. So upon that thought, I have substituted s is equal to minus 1. Okay. After substituting the minus 1 value, so I got the a value is equal to 1, approximately equal to 1. Now similarly finding the b value, to have the b value, you have to take such a value of s so that a value and c value should be equal to 0. So the value of s is equal to minus 0.5 into j into 0.86 is in the previous equation. So I got the I have substituted that value, so that I got the value b is equal to minus 0.5 plus j into 0.288. Students, you can check these entire calculations using the calculator. So I find out the b value. So a value I got, b value I got. Now the time is to find out the c value. Once I observed that here in the roots calculation, the roots of b and c values are conjugate to each other. So if I find the b value, definitely if you take the conjugate of b, that will be the value of c. So minus 0.5 plus j into 0.88. The conjugate of this one is simply changing the sign of imaginary part. So the c becomes, c is equal to minus 0.5. So in place of this, if you substitute minus j into 0.88, so you got a, b, c values. Now I am going to substitute that in the h of s equation. A value is 1, b value is minus 0.5 plus 0.288j plus divided by s plus 0.5 into j 0.866 plus 0.5 minus 0.5 minus 0.288j by this value. Okay, you got a, b, c value, so a and this value. So at last we have to substitute, we got the values of a, b, c, and we have to represent this value as ck by s minus pk. You have to convert that into ck by s minus pk. You have to represent that in the ck by s minus pk, so that only you can apply the impulse invariance technique. So to have this, if ck is 1, yes, minus I need to get right. So here this plus I am writing it as a s minus of minus 1. So pk at p1 value is minus 1 will become. So here also, if it is this, yes minus of this I can write, and here also yes minus of this. So I wrote. So now according to the impulse invariance technique, if h of s is equal in this form, ck by s minus pk form, then h of z equal to ck by 1 minus pk into t into z power minus 1, where t is equal to 1 second here. So according to that, I am representing this 1 by 1 minus e power minus pk, p1 is equal to minus 1 into z power minus 1 plus this into, this is ck, this is constant, minus 0.5 plus j into 0.288 whole divided by 1 minus, what is the pole? 0.5 minus 0.5 minus j into 0.86 minus 0.5 into e power minus j into 0.866 is the value. Same here also 0.5. Guys, here you can change this as 0.5, this, yes, some small mistake is you can correct. E power 0.5 into e power 0.5 minus 0.866 into z power minus 1 plus minus 0.5 by j into 0.288 by e power minus 0.5 into plus 0.86 into z power minus 1. So this is the value. I think this video clears your doubt. So simply you have to represent your h of into this form. In this form you will identify the pk. Pk is the pole, right? This form. Then in this you have to identify the pk. So if you have to place this pk at this point, at these values. That's it.